Okay, well, here we are. This is going to be our craft project, creating your own triboelectric nanogenerator. Okay, so we're going to need a few different things to make this work. First off, you're going to need a few of these connectors. These are called DuPont connectors, and you're going to need the female kind. And frankly, you don't need this many. You just need two. Okay. And then you're going to need at least two paper cards. These are business cards, but you can use whatever you like, including 3x5 cards, which are very easy to find at most stores. Most stores that sell that sort of thing. Then you're going to need packing tape, not the kind with the glass fibers in it, but just a nice clear packing tape. Maybe it doesn't have to be clear, but nonetheless, you might be able to use other kinds of tape, but I found that the packing tape works pretty well for this. This happens to be a Home Depot brand, but whatever. You'll probably want a black straw. That will be helpful in what you're doing. Some regular old cellophane / Scotch tape, or cello tape, as they call it across the pond, and some tin foil or aluminum foil. Now, as for getting these things, which you can buy a pack of them for $5 or $6 online. This is one brand. There are many brands. And of course, the magic component that you will need is a green light emitting diode, preferably one with a clear plastic enclosure or lens. Okay. All right. So, again, you can usually buy these online for a bit, or if you're lucky enough to have an electronics store around, you might be able to buy some of them there. Okay. So the first thing we're going to do, and if you are a youngin', have a grown-up help you with this part, okay? First thing we're going to do is we're going to take off the ends of these. Now, these are male ends. These are female ends. And the male ends here, it doesn't really matter what kind of end you have here because you're going to cut it off. If you get one with two female ends that's really long, you might be able to cut it in half and use two of them. So that would be cool. Anyway, there's about a dozen ways you can strip the wire. We're just going to take this set of linesman pliers and we're going to cut them like that. And then I'm going to take this cute wire stripper here, which is all complicated, and we're going to set this to about, let's see, what do you want to strip off? Maybe about a ½ inch of wire or so, or a ½ inch of insulation, or maybe 9/16. I don't know, something like that. So we're going to strip that like that. And we're going to strip that like that. Okay. And usually I would recommend that you twist these together, but I don't think I'm going to do that this time. You're probably better fanning them out just a little bit. Let's see, let's strip off just a little bit more. Okay. All right, now the goal here is we're going to make a gadget. Always dispose responsibly of your little bits of insulation so your pet rabbit doesn't eat them. Let's see. Now we're going to take the cards here. We're going to take two of the cards. Let's see, these are business cards with names on them. I scribbled them out, but I didn't bother scribbling out the logo. Now you need to take one of the cards and cut a little bit off one side. This makes it so if you put the two cards together edge to edge, one or both of them kind of bow out. See, they make a little thingamabob here so that they kind of have some natural space between them. Okay? All right. Now, what we're going to do is we'll come to the black straw. We'll get to that later. Okay, now what we're going to do is we're going to get some foil. My foil's a mess. I hope your foil is in better shape. And we're going to cut a piece of foil. Yeah, maybe we'll cut it the same size as the card. But eventually it needs to be smaller than the card. Please excuse my camera work. I'm still getting used to this whole camera thing. It wasn't that many centuries ago the camera was invented, so you know. I should probably fast line through this part. Okay. All right. So right now the foil is way too big. We need the foil to be smaller than the card. How much smaller? Well, you know, I don't know, like smaller. Maybe a little smaller than that. That's looking okay. We'll give it a little more of a border. It's important that I have a border for a few reasons. But mostly the tape won't stick if you don't have a border. Okay. Now we're going to make, let's see. Now, don't worry if your border's not perfect. It's, you know, I spent way too much time cutting that, but you guys will be okay. All right, now we take our wire, and we take the end that's all kind of frayed out, right? And we're going to kind of put that on top of the foil. Okay, on top of the foil. All right, now we're going to get packing tape here. All right, and we're going to put that on top of, whoopsie doodle. Now, I'm being a bit of a perfectionist, but, you know, it'll still work if it doesn't look exactly like mine. We're going to put that on top. We're going to make a nice sealed doohickey here. Okay. Now, on the ends, you can trim it off, or you can, if it's not too much, you can just kind of bend it around. You know, if it's not exactly centered, that's okay. And you're going to have to make sure that the wire can come out okay. Now, later on, we're going to use this other tape here. Now, you don't necessarily have to use the other tape. As long as you see, we're going to put the two cards together, right? And it's going to, you could just use the regular tape to wrap the two cards together, but it doesn't really give room for the, or I mean, you could use a packing tape to get the two to hold together, but it doesn't really give room for the wires to come out, which is why I kind of like using the cellophane tape here. And don't be like me, always keep a tidy workspace. Well, that's going to stay on the table, I think. Okay. Now, what we're going to do is we're going to do exactly the same thing again. I think I'll pause it for this. Now again, remember you cut one of these a little shorter than the other one. It doesn't matter which one of these is the shorter one. Just remember that the foil for that one might need to be a little shorter. In this case, it looks like the foil patches are about the same size, but this has the tape on it. And also we taped on the connector here, the DuPont connector on the wire here. Now, we're going to put these together, and here's the important bit. Paper must touch tape. That's the critical part of this whole thing. It's the paper interacting with the tape that makes this thing go. Well, I mean, you know, there's more to it. Of course, we have to have the foil patches. The foil patches collect electric charges, but the electric charges transfer between the paper and the tape because they are at different electrostatic potentials. What does that mean? Well, it's kind of hard to explain, but electrons like one more than they like the other. So when they come together, they'll jump across. Okay? And then when they come apart, they'll jump back. And that, we can use that to generate electricity, just small pulses of electricity that are higher in voltage than you would guess. So this is exactly the same thing, triboelectricity, tribo meaning rubbing or friction. This is exactly the same thing that happens when you rub your feet on the carpet and you touch the doorknob and it gives you a zap on your knuckle. Now, some of you live in humid climates where this never happens, and some of you live in climates where this happens all the time. Cold, dry climates are more likely to experience this, okay? All right, so we're going to take, I think we're going to take this shorter one here. We're going to put it on, let's see. No, we're going to take the longer one and we'll put it on top of the shorter one. Again, it doesn't matter. All that matters is that you have a bare side with just paper, and it's okay if the paper has some printing on it. That's okay. And then the other side is the tape side. Okay, so these two are identical, but we're going to stack them one on top of the other like this. Not with the foil facing each other. Okay. Again, I hope we've all gotten that point. All right, so so everybody gets to look as I awkwardly try to demonstrate manual dexterity. So I'm just going to put a little piece of tape there. Again, if you figure out a clever way to do this with the packing tape, that works just fine. It's just, you'll need to make a slit in the other side of the packing tape so that these guys can escape. Okay, so now we'll kind of bow that out. Okay, we'll kind of line that up. We'll put the tape here. Listen, if I can do this, you can do this. Because obviously I'm awkward. Yeah, my tape's all kind of folded up, and you know what? That's okay. It'll work anyway. It'll taste just as good even though the cookie's cut in half. That's what my mama told me. Okay. All right, now, you've got this doohickey here, this sandwich, right? And it's got enough of a bow in it that you can kind of do this with it. You kind of tap it or slap it, and it kind of mashes down. Now, eventually it might get mashed down and not bounce back up. And, you know, that's okay. You just kind of fiddle with it until it does bounce back up. And if it never bounces back up, well, you know, you can make another one because they're not that expensive. Okay, now comes the magic part. Okay, so now we've got the LED here, light emitting diode. It is important that you use green. I'm sorry, I hope that didn't make you thirsty. It is important that you use green, okay? One of the reasons for that is your eyes are most sensitive to the color green. Another reason is usually it's best if you use a green super bright or super intensity or super efficient LED, because this doesn't make a whole lot of energy. Now the voltage spike's much higher than you would expect. It's probably 50 to 100 depending on the size of your card, but it's brief enough that it doesn't blow out the LED, and it doesn't deliver a whole lot of oomph. It's very it just doesn't shove a whole lot of current through it. So I got this in a pack of 100 for like $6 or whatever. You can buy fewer of them and get by just fine, okay? Now, the reason we got these female connectors is, let's see if we can zoom in on that a little bit. 1 moment, please. Oh gosh, that's a super zoom. All right, you probably can't see it, but there's a little hole in here, okay? We're gonna take the wire on the end of this, which we call a lead, and we're going to shove it in the hole here. And then we're going to do that on the other side too. This had better work the first time. Okay, so now we've got this doohickey here. Okay, let's check. Oh, look at that. Oh my gosh. Oh, it doesn't seem to be working super consistently, but that's okay. Sometimes it needs a little breaking in period. Or sometimes things just need a little adjusting. One weak point is, of course, here where the wire touches the foil. Sometimes you need to mash that down a little bit. Well, it doesn't seem to be working again. So we'll fiddle with that. Just a moment. So let's zoom out a little. Well, I'm troubleshooting that, which again, sometimes they just need a little time to, adapt or something, and you just double check them. But so usually after you slap them a few times, they start working just fine. So I would take a black straw and cut. Well, this is one of these that's like 5 millimeter diameter on the interior. I don't know what that is in inches. I'm not going to compute it right now, but cut off maybe about 1/3 of the black straw, and you can put it around the LED so that it gives you a little tunnel to look in so that it blocks out the light around it. Okay, I guess maybe we need to wake up and choose violence, as it looks like this requires a little more of a slap. So if we zoom in here, take a look down the barrel here. There we go. So I guess you have to really feel some frustration to get this to light up. Okay. Now, mind you, if you get bigger cards, they're gonna work better. Well, I don't know. This seems to be kind of inconsistent, but I'm not sure. Again, we did put it together out of paper and tape, so I can't exactly say which part of our precision engineering failed, but it's working most of the time. You can see that. Okay, so congratulations, you have now made a triboelectric nanogenerator that makes electricity that you can demonstrate, demonstrably electricity from slapping, from the little light blinking. there you go. So thanks, and we'll show another experiment in a bit. Okay, so here's an experiment for you. First experiment here is we take the LED and we slap it, and we notice that this lights when we hit it. No big surprise there. That's when we put energy into the system. Now, the electrons are there all the time, but they can't move around unless there's some motive force. And that motive force is you exercising your aggressions on the poor little tape here. So now what we're going to do is we're going to take the LED. We're going to pull it out. Notice one is longer than the other. One wire, one lead is longer than the other. We're going to shove it back in here the opposite way. We're going to put our thingamabob back on, or excuse me, our straw, and then we're going to do this. Okay, so not so easy to see. But notice that it doesn't light until I actually lift my hand from the thing. So for some reason, instead of it being on the downstroke, it lights on the upstroke. Now that's something to consider, okay? So what happens is when you shove the two together, the electrons go one direction. And when you lift your hand off, the electrons go the other direction. So this is a light-emitting diode, and it only emits light when the electrons are flowing in the correct direction for it relative to the little doohickey, relative to the little chip of silicon inside it. So, or gallium arsenide or whatever it is. So basically, it's generating electricity. It's going one direction when you slap it down and another direction when you lift it off. So there's the first experiment that you can do just with this simple setup. But we will show some other experiments with if you add some extra stuff in a little while. Okay, so we're back for a third installment of the Triboelectric nanogenerator. And for this, you're going to have to spend a little more money. And this is a little more advanced. So what we need here is the original Triboelectric nanogenerator we made in part 1. And we will need 2 light-emitting diodes. By the way, kids, if you're a really heavy person and you purchase your chairs from a secondhand store, just be prepared if they collapse underneath you. It was dramatic. It's lucky I didn't go through the glass door behind me. Okay, so then you need this thingamabob. This is called a breadboard or a solderless breadboard. It is not used for cutting bread. It is used for hooking up electronic components. So this here is an electronic component, and it's got tiny little spring clips inside all of these hundreds of little holes, okay? And these are all hooked up. Let's see. Do we dare peel the back off to show? Oh, there's nothing to see. The way to explain it is these are wired together like in these columns like that. So it's like everything that's on one here is wired together. Everything on 2 is wired together. So if I put this electronic component like this, so both of the leads are attached there, then the 2 leads are connected together and no electricity can flow through the component. If I put it across 1 and 2 here, then if something's hooked up to 1 and something's hooked up to 2, electricity can flow in and out. Okay. Now up along here, these are actually connected lengthwise all the way along, and they're called distribution buses. They're like, so you can put like, the positive side of a battery hook up to here and the negative side of a battery hooked up to here, and then you can just like run wires off of those to provide electricity for everything. So, all right, now in the first installment, we made a choice to put female connectors on here. Now, maybe we didn't make that choice. Maybe I just told you that that's what we were going to do. Now, if you make another one of these and you're only going to be plugging it into a breadboard, you could just use the male side instead, or a male side. Some of these come female to female, some of them come male to male, some of them come male to female. Okay? So, in this case, we've got female, and so in order to get them to hook into the breadboard, we're going to need some of these. Now, these are what are called header connectors. Again, if you are lucky enough to have an electronics store by you, you can pick up some of these. They're not terribly expensive. You can get them online, but you'll probably have to buy 60 of them. Now, the thing about these, and these are on 1/10 inch centers, 0.1 inch centers, okay? Also 2.54 millimeters. Okay, so now these are extra long ones. So if you're going to work with a breadboard, you want to get extra long ones, because the usual kind are about half this height and aren't useful for breadboards. Okay, so we're only going to need a small piece of this. So usually you get a pair of pliers here, and it doesn't matter which kind. These are linesman pliers, but you can use just anything that has plier in the title, and we're just going to snap off a pair of these. Now, every once in a while you do this, and a pin just falls out uselessly, and well, that's okay. Header connectors are cheap. You can get another one. It's okay. All right, so let's zoom down onto the, whoa. Okay, let's zoom down onto this board here, and we're gonna put the little header connector into 1 and 2. Or you could put it anywhere you like, really, but you know, this is just one little corner here. And then we're going to take one LED. It doesn't matter how you put these in, but they got to be opposite each other, okay? So we're going to take the one LED, and notice, let's see. Focus in. Focus in, buddy. Bring us in, buddy. Okay, notice that one leg, one lead, one wire is longer than the other. Lead is probably the best thing to call these, but you can call it a leg if you like. But it is, of course, a wire. Okay, so we're going to put that one to our left as we plug it in. And then we're going to take the other one and we're going to put it to our right as we plug it in. Okay, and as long as these are bridging 1 and 2, we're good. Okay, now we're going to turn this thing like this, and we're going to take our Triboelectric nanogenerator, and we're going to plug the little bits on like that. Let me see. It's there a way to do this that makes it more visible? There you go. Careful not to poke your finger. If you need to use a little bit of force, be sure that you are really centered on there. Okay. Well, let's see. I'm going to switch it around because I like to have it go in the other direction. Okay. So now we're going to zoom out a little bit. Okay. So now we've got a doohickey here. Okay. So now what we notice... Okay, what we notice is nothing's happening. All right, let's try that again. We're going to zoom in. Maybe we'll dim the lights. Let's dim the lights, shall we? Oh, something happening. Let's see. So you can see these are kind of sticking way up. You can see why you might want to have longer wires on these. I'm going to kind of bend these up a little bit in the hopes that that helps this lay flat on the table. And we're going to... Okay, so I see some glimmers here, but let's take a closer look. Of course, this works better in the dark, but in the dark I can't use a camera so easily. All right, so let's do this. Let's move one of these LEDs over here and one of these LEDs over here so that they're both pointed pretty much straight up at the camera. There, okay. So you can see they each have a little... They each have a little dish that's holding the little chip, so that helps that acts as a reflector. So let's try this. Oh, that's perfect. Okay, so now you can see down, up, down, up, down, up. So you can see when I slap it, one LED lights up, because the electricity is going one way, and then when I let off, the other LED lights up because the electricity is going the other way. Not only that, it looks like the release is a little stronger than the slap. Is that just because of how it's pointed? Well, let's take a look. Let me see if I can point that straight into the camera. Well, sometimes both of them seem to light up. I'm guessing that there's probably a little bouncing on the slap where it kind of goes back and forth a little. Sometimes there's a little bit of flashing on one or the other. Okay. So not super consistent, but you can see that for the most part, when you let up off of it, so just to zoom out so you see, so it seems to be very consistent when you let up off of it. When you slap it, there's all kinds of bouncing and electricity and stuff going on, and so it's a little crazy. So in our next thing, we will see how we can use this to light the same LED on both the downstroke and the upstroke, or both the smash and the release. Thank you very much. Okay, so here we are again. For our next trick, we're not even going to use the TENG, the Triboelectric nanogenerator. We're actually just going to use the breadboard and a pair of LEDs, which you probably can barely see because they're water clear and they're not glowing right now. Okay, so we've got a pair of LEDs here. Now, this is kind of fun because there's an experimental aspect to this, like there was when you first plugged an LED into the slap generator, or the TENG, or the TENG, which was when you first plugged it in, you didn't know whether it was going to light up on the slap part or the release part. So on this, we're going to hook these two LEDs are electrically hooked together, because notice that both of their wires are hooked into the one side, and both of the wires on the other side are hooked into the two side. So what we're going to do is we're going to put a black straw around one of them so that we can see that independently of most of the lights in the room or whatever else is going on. Whatever else is going on is a big hint there. Okay, so we're going to zoom in here, blah, blah, blah. All right, now let's see if we can get a glimmer down the tube there. Yeah, okay. Now what we're going to do is, you can always put a little wrap of electrical tape around the bottom of this to kind of fix it onto the thing, or kind of, well, anyway. If you're lucky enough to get straws that are just slightly smaller than your LED, then you kind of have to jam it on. That's pretty cool. Okay, so now you take a flashlight. Okay, my flashlight has too many modes. And you take this other LED and maybe you bend it away a little bit. Okay, you're going to take your flashlight and you're going to shine it into one of the LEDs. While looking at the other LED. And, I mean, a little bit of light's leaking around, but not a lot's happening. Yeah, wrong flashlight. Okay, now what we're going to do is we're going to take this other LED, and we're going to, like I said, this camera thing is new to me. It's invented in, what, the 1700s? And we're going to flip it around. So that basically these things have the long leg on the same side. The long leg is on the same side. Let's double check that. So this long leg is on the right. Long leg is on the right. Now, mind you, I flipped this over, so, you know, if I used right and left in another video, it's all relative and it's not going to apply here. So let's see if we can, all right, now let's try shining a light down here. Oh, it looks like this strobes. Let's try this again. Oh, do you see green? Look at that. There's a little bit of green in there. Weird. So what does this tell us? Well, I'll tell you what this tells us. This tells us that an LED can work backwards. It can make electricity from light. Now, it's not terribly efficient at it. There are other things that are better at it, like solar cells, for example. They're better at making electricity from light, but they use different colors of light than this, mostly infrared and red colors. But as you can see here, this generates just enough electricity to light up, to dimly light up one of the other guys. There's so much light leaking through that it's a little hard to detect, but the green color is really distinct. If you get that flashlight right on there, you can see the green. So, this is basically using one LED as a solar cell, not a very efficient one, and one that uses only longer colors, and the other one as a light emitter, as an LED. So what do you think of that? Thank you for watching.